Hello, and welcome to this video on new mathematical theories and proofs. In this video, we'll explore some of the most exciting recent developments in the field of mathematics, from the proof of Fermat's last theorem to the ongoing quest to solve the Riemann hypothesis. Let's start with Fermat's last theorem, one of the most famous open problems in mathematics. It states that there are no three positive integers a, b, and c that satisfy the equation a to the power of n plus b to the power of n equals c to the power of n for any integer value of n greater than 2. This theorem was first proposed by Pierre de Fermat in 1637 but remained unproven for more than 350 years. In 1994, Andrew Wiles, a mathematician from Oxford, finally cracked the problem after years of secretive work. His proof relied on advanced concepts from number theory, such as elliptic curves and modular forms. The proof was hailed as a major breakthrough in mathematics and earned Wiles the prestigious Abel Prize. Another recent mathematical controversy involves the ABC conjecture, which was proposed by Shinichi Mochizuki in 2012. The conjecture connects the prime factors of three integers a, b, and c in a certain way and has far-reaching implications for number theory. However, Mochizuki's proof is notoriously difficult to understand, and many mathematicians have struggled to verify its correctness. The controversy highlights the importance of clear and accessible communication in mathematics and the challenges of peer review in a field with so many complex concepts. Let's move on to the Riemann hypothesis, a conjecture about the distribution of prime numbers proposed by Bernhard Riemann in 1859. The hypothesis states that all non-trivial zeros of the Riemann zeta function lie on a critical line in the complex plane. Although the hypothesis has been tested extensively and seems to hold true for the first trillion zeros, no one has been able to prove it rigorously. The Riemann hypothesis is considered one of the most important open problems in mathematics and has inspired numerous attempts at a proof, including by some of the greatest mathematicians of the past century. The Riemann hypothesis is just one of many open problems in mathematics that have yet to be solved. Other notable examples include the Hodge conjecture, which concerns the topology of algebraic varieties, and the Navier-Stokes equations, which describe the motion of fluids. The pursuit of these problems often requires collaboration between mathematicians from different fields and the development of new techniques and approaches. The ongoing search for solutions is a testament to the power and versatility of mathematics as a tool for understanding the natural world. Speaking of new techniques, let's explore some of the latest methods in mathematics. One of the most exciting areas of research is topological data analysis, which uses tools from algebraic topology to study high-dimensional data sets. This approach has applications in fields as diverse as neuroscience, physics, and computer science. Another emerging field is knot theory, which studies the properties of knots and links in three-dimensional space. Knot theory has connections to many other areas of mathematics, including topology, algebra, and geometry, and has potential applications in quantum computing and cryptography. Artificial intelligence is also making its mark on the field of mathematics. Machine learning algorithms have been used to solve complex problems in algebraic geometry and number theory, such as identifying patterns in the distribution of prime numbers. Additionally, AI has been used to discover new conjectures and theorems, such as the discovery of a new prime number in 2018 by a collaborative effort between humans and AI. However, the role of AI in mathematics also raises important questions about the nature of mathematical discovery and creativity. Can a machine truly understand the beauty and elegance of a mathematical proof? Or is there something uniquely human about the way we approach and appreciate mathematics? The impact of mathematics extends far beyond pure research and academia. Mathematical concepts and techniques are used in fields as diverse as physics, economics, engineering, and computer science. Advances in cryptography, for example, have enabled secure communication over the internet, while optimization algorithms have revolutionized supply chain management and logistics. Moreover, mathematical literacy is increasingly seen as a vital skill for a variety of professions, from finance to healthcare. Encouraging more people to study and appreciate mathematics could have far-reaching benefits for society as a whole. Despite the many exciting developments in mathematics, the field still faces numerous challenges and opportunities. One challenge is the lack of diversity and inclusivity in mathematics, with women and people from underrepresented groups being underrepresented in the field. Encouraging greater diversity and inclusivity in mathematics could lead to new perspectives and ideas and ultimately advance the field as a whole. Another challenge is the need to communicate mathematical concepts and ideas in a more accessible and engaging way. As we've seen with the ABC conjecture controversy, clear communication and peer review are essential for ensuring the accuracy and reproducibility of mathematical results. In conclusion, the world of mathematics is a rich and diverse landscape that continues to offer new challenges, opportunities, and discoveries. From the proof of Fermat's last theorem to the ongoing quest to solve the Riemann hypothesis, the field of mathematics is full of exciting and inspiring stories. As we continue to push the boundaries of human knowledge, let us never lose sight of the beauty and elegance of mathematics and its potential to transform our world. Thank you for watching.